All right, so our next topic is networks. So networks is a type of generally a graph. So, and we're going to look at it. So with this graph, we have things called vertices. So the vertices are the dots on this graph. So when we see a diagram like this, it's called a network because we're seeing how things are connected to each other via sort of either and what we call an edge or a path sort of thing. So an edge. So the vertices or the vertex is one. So here the vertex are the people, okay? And then we have how they are connected to each other. And that's represented by a line, which is called an edge. So, like we have seen this in matrices. Remember, we had a network for communication, and this is an example of that. It's a communication network and how people can connect with each other. So we can see here that, Brett is the only person who can directly talk to Ethan, but, Cara can get a message to Ethan via other connections or vertex. So what we're going to look at is all the bits and the elements of the graph. So here networks becomes a lot about definitions, so we have to be very careful and we make sure we know. So we've got a graph is a diagram that consists of a set of points called vertices. So vertices is the plural. So when you have more than one, you say vertices. If you've got one, as you can see up here on the diagram, they call it a vertex. Okay, and the lines are called edges. Now, if you have a loop is an edge that goes out from the same vertex and into the same. So you can see here, there's the loop. Okay, that's what a loop is. If you have more than like one edge connecting two vertices, so see, like you could say they're multiple edges. So that's like here. So you've got two vertices. We've got two ways of getting to each of them. So that's called multiple edges. Sometimes they call that, just so you know, they might call that parallel edges as well. So you might want to put that then. Parallel just means it's not the literal sense of parallel, but if they're going from the same to it, that's how they may call it. Okay, so the next thing is the degree of the vertex. Now, the degree of the vertex is the number of edges attached to the vertex. Or what you might want to say is maybe the number of entranceways, because it might make it a little bit easier to determine. So if you have a look, for example, up here on our, or we'll look on this one down here. So see how A it's got one entryway, two, it has this 3, and that's 4. So it has a degree of 4 because there's four ways into it. So B has a degree of 2. Now C, if you look at it, you've got this one coming in here, 2, and then you also have the loop. So the loop has 2 ways going in as well. So then this one's degree, the degree of C, would be considered 4. So maybe up here, you need to know that a loop has a loop equals a degree of 2. Okay? It is actually just one edge. So the loop, the edge itself is just 1, but it creates a degree of 2 because there's 2 ways in. And that's a little trap that you often get in some questions. All right, and then lastly, D's degree. The degree of D is also 2. There's 2 there. Okay, so then we've got this little formula here. And it says, in any graph, the sum of the degrees. What does sum mean? Total, you're adding up. Yeah, when you add up all, yeah? So the sum of the degrees of the vertices is equal to twice the number of vertices. So, a number of edges, sorry. So if you want to just write that, you could write the sum of the degree equals 2 times the number of edges. So over here, so if I did this for this example over here, if we counted out how many vertices, we've got 1, 2, 3, 4. And if we had a look and we just looked at how many edges this graph actually had, I'll highlight them for you. We've got 1, 2, 3, 4, 5, 6. So we have 6 edges there. So we would say this one, in this example, its sum of the sum of degrees should equal 12. So let's have a look at it. If you've got 4 plus 2 is 6, plus another 4 is 10, plus this 2 is 12. So it did equal that, yeah? So just to show you that that worked. Okay, so we say a vertex is even degree if its number is even. So this one is an even vertex, and because it's these ones all are, because it has they're all even numbers. If we had an odd one, we'd have an odd vertex. So just to show you, I'll do an example of an odd one. So if we did this degree would be 2, this one's degree would be 3, and this one's degree would be 1. So these ones are odd vertices. Okay, so they are odd vertices, those ones. Okay, so let's have a look at this one. Consider the graph shown. How many vertices does this graph have? So you're just counting up the dots. So with these vertices, so for this one, the vertices, there's actually 4. So there's 4 points, and just so you know, so that's A, B, C, and D, they called them. Okay, in B, how many edges does this one have? So you might want to just check with highlighting them. So you got 1, 2, 3, 4, 5. So we've got the edges equals 5. Next one, it's asking what is the degree of A. So the degree of A equals, so A is there's 2.
You got the edges or missed there's 6 edges.
Oh, was there 6? Sorry.
The loop. The loop. Yeah.
Oh yeah, I didn't miss that one. So good work. So the loop, there was 6. Sorry, 6 edges, and the degree of A was 2. D, the degree of D equals, now, so remember with the degree of D, now the loop counts as 2. There's 1, 2, 3, 4. So there's 4 entryways into there, so it has a degree of 4. And then it says, what is E? What is the sum of the degrees? So the sum of the degrees, you can even just either go, you could either just say 2 times the edges, which would be 12, or you could double check it for yourself. So we said this was 4, this is 2, this is 4, and this is 2. Does that add up to 12? Yes, it does. Okay, so here's just a little summary. So a graph is a diagram that has vertices and lines, which are called edges. A loop is something that goes back to itself. So a loop is 1 edge, but a degree of 2. Okay, so we know what the degree, and we know the sum of the edges is twice, the sum of the degrees is twice the number of edges. Okay.